It's okay. Now I'm starting my second presentation. I'm honored to be able to present two presentations here. Actually, I'm not the first author of this paper, but the first author is busy, so I stand in here for him. To begin with, the subject of this work is about the expanding input space of a small smartwatch. Okay. Touch gestures are familiar to use because it is intuitive and we are already familiarized by using the other devices such as smartphone. Maybe from this advantage, most of the commercial smartwatches have a touch screen. However, touch screen on the smartwatch is too small. The tiny touch screen worsens the occlusion problem and requires too much clutching for using touch gestures. Therefore, previous researchers presented the various designs to solve these problems, such as using mechanical manipulation or using the edge of the touch screen or extending input space to the around space. These techniques were adjusted to the problems of the tiny touch screen. However, those are required a user to learn new input techniques. Hence, we suggest the concept of transfer. The goal of transfer design is extending input space with using the familiarity of the touch gesture. In transfer, touch gesture is not only still used, but also there is no discrete boundary between the touch screen and its around space. In other words, we try to make a user can do a gesture in the air with the implicit and natural transition from the touch gesture on the screen to its around space, as shown in this video. Before explaining the transfer itself, now I review the touch gesture interaction. When users interact with the touch screen utilizing touch gesture, they face the two states, touched state and out of range state. Then to design transfer, we introduced one more state into the state transition diagram. It is named glue state. Glue state is gluing state between touched state and out of range state. Role of the glue state is to make a gesture can be continuing in the air from the touch screen. Then now I introduce how transition is occurred between the states while in user transfer. The first step to use transfer is gesture registration. In this step, a user can choose which gesture to use in glue state. As I mentioned before, there is no discrete boundary between the touched state and glue state. Therefore, we choose the traditional touch gesture as a gesture registration action. For example, if a user wants dragging gesture in glue state, a user do dragging gesture on the touch screen as the registration action for dragging in the air. And the next step is relaxation action for state transition from touched state to glue state. After a finger released from the touch screen, a user can be done touch gesture or can be start continuing gesture in glue state. So if a user wants to do continuing gesture in the air, users should do a relaxation action. After the relaxation action, a user can continue gesture in the air. Then finally, a user can be done transfer with terminating action. And to make a round space as a continuous input space from the touch screen, some design issues exist. Now I explain the issues in designing transfer. The first issue in the relaxation action. Relaxation action is needed to distinguishing traditional touch gesture of releasing action and relaxation action of transfer. Then to make a natural transition between touched state and glue state, it is important to find the implicit but reliable action to distinguishing releasing action and relaxation action. The second issue in the glue state. In case of the touch gesture, a user can recognize that they do gesture on the touch screen because there is tactile feedback between the finger and the touch screen. However, if a user does gesture in the air, there is no feedback for recognizing whether close state or out of range state. Hence, here is to find the proper feedback to let a user know the current state. And the third issue is designing terminating action. Terminating action should be easy to use, but should not occur accidental transition from closed state to out of range state. And the final issue in transistor design is designing multi-touch transistor, especially about the starting action of pinching and gesture. If we design pinching in gesture as similar to the single touch transistor, gesture registration action should be chosen as a pinching gesture on the touch screen. However, after doing pinching gesture, there is no space to move their finger in the air, as you can see in the video, and hence here leads to design alternative starting action for multi-touch transistor. As our first step to design transistor, we conducted observation study. The goal of this study is collecting the common features of finger movement while using smartwatch. To do this, we tracked finger movement while participants used conventional applications of a smartwatch, such as searching an image, finding a contact, checking time and schedule, etc. Then analyzed the finger movement pattern for designing relaxation action with mainly data of tapping, dragging, and flicking gesture. Because maybe I have not much time to presentation, so I will skip some details. You can see details in the paper. And as a result of analysis, we find the two features can be using in designing relaxation action. First one is the rest touch position, and next one, and the second is finger movement speed and direction after the finger movement speed and direction after done a dragging or flicking gesture. Based on the two distinguishable features of a finger movement after a touch gesture is done, we set a relaxation action to a finger movement that keep moving after crossing the bezel of the screen. Another finding is about relative movement between the fingers while a user do single touch transistor. First one is height difference between the fingers. First one is height difference between the fingers while they do a single touch transistor. In case of the height difference is widely varied in single touch transistor, but in the two-dimensional distance between the fingers, it is not much changed while a user do single touch transistor. Based on this finding, we can design alternative starting action for multi-touch transistor. We design a starting action for pinching gesture by using the 2D distance change while one finger is on the touch screen, as shown. One finger is on the touch screen. Okay. And based on the result, we designed the transistor as an early design for the following experiments. This is a simplified state diagram for transistor. First, a user do touch gesture on the screen for gesture registration, and then a user keeps moving across the bezel of the screen. Then a closed state is starting. After continuing gesture in the air, then if a user wants to quit a gesture, a user can lift a finger above around the space as a terminating action. In our early design, we just set our finger lifting action with height threshold to the terminating action as similar to touch gesture. Then we conducted the experiment to verify the feasibility of design of a relaxation action. To show the feasibility, we use a dragging task with 3 different travel lengths, 10 mm and 12 mm and 40 mm. 10 mm travel length can be done with touch gesture only, and 12 mm 20 mm travel length also can be done with touch gesture only, but it can be done at the boundary of the screen. And finally, 40 mm travel length should be used transistor because the screen width is shorter than 40 mm. And the results show that designed relaxation action was well working. In case of 10 mm target, all trials had been done with touch gestures. But in case of 20 mm target, some trial had been done with transistor, even if it do not need to use a transistor. But this accidental activation only occurred 0.52% from whole trials. And in case of 40 mm target, some trial failed to activate transistor, but this unsuccessful activation only occurred 0.87% from the whole trials. So this designed relaxation action is well working. And we can also get a finding from this experiment about the terminating action. In this experiment, we designed a terminating action with height difference between the screen and the finger was used for terminating action. If a user lifts a finger above the around space, glue state is done. However, some participants mentioned that terminating action with height difference were hard to perform because perceived input space did not match the device coordination. To solve this problem, we analyzed the finger tracking data from this experiment. And then as a result, we can find finger movement speed along z-axis in glue state is distinguishably slow than the speed at the moment before terminating action. Therefore, we redesigned terminating action rather than using height difference between the fingers and the screen. So King lift up action set as the terminating action for single touch transistor. And actually here in the paper, 2 more experiments exist, but I'll skip these experiments to further time. As a summary, now I explain the final design of transistor, and it is about the single touch transistor. First, the user do touch gesture on the screen for gesture registration. Then a user keep moving across the bezel of the screen as the same to the early design of transistor. And when the glue state is starting, haptic feedback is given to users as a feedback for glue state starting. Then a user can do continuing gesture in the air. After that, if a user wants to kill a gesture, a user can do quick lift up gesture as a terminating action. When the glue state is done, as the same to the starting of glue state, haptic feedback is given to a user. And then this is the demonstration video to show how it works the single touch transistor. In the glue state, and then king lift up to done. And next, it is about the multi-touch transistor. State transition is same to the single touch transistor, but in multi-touch transistor, gesture registration and relaxation action was combined as a starting action. To starting a multi-touch transistor, a user opened their fingers while one finger touched on the screen. And when the glue state is starting, haptic feedback is given to let a user know the glue state is starting. Then a user can do continuing gesture in the air. After that, if a user wants to kill a gesture, a user releases a touched finger, zoom in zoom in the picture when the color state is done. When the color state is done, haptic feedback is given to a user to let a user know color state is done. This is the demonstration video for multi-touch transistor. As I show that while a zoom is on the screen and then 2 fingers distanced, multi-touch transistor is starting. Okay, it's done. We investigate the concept of transistor in this paper. The goal of using transistor is to bring the experience of a large touch screen device into a smartwatch usage. In this study, we focused on dragging and pinching gestures as a single touch and multi-touch transistor, but it can be generalized to other touch gestures from our findings. Our findings may provide a guideline in future studies to utilize the space around the touch screen as an extended input space for a multi-touch interface. Thank you.
Time for questions.
Hi, I'm Victor Chang from Carleton University. Very interesting work. I like wearables a lot, so I appreciate your hard work. I have a question about, so in your case, your prototype right now uses an optic track system to track the movements. So I just want to see what's your plan for future work so that you get rid of optic track, and how you're going to track the finger movements. Later on, if you want to walk in the street, you don't have the optic track system with you. So how are you going to do that?
Yes, actually, we will not be due for a tracking system, but just we anticipate that if the technology will be better, the transistor is useful to smartwatch. Yeah.
Anybody else? Yeah.
I just wanted to answer to your question that on Wednesday morning, one of the papers presented from SUI was that side sensor, which allows you to detect touch on this, around the phone. So
Yeah.
you can have a lot of different technologies, I guess, to detect.
So I have a quick question. Maybe the next speaker can get ready. So I've seen your model. Most of your gestures start with the touch, right?
Yeah.
So you showed it maybe a little bit in your last video. Imagine I want to start the gesture outside of the touchscreen.
Yes.
So I want to do something like this. I saw that if you can pin one finger on the touchscreen to do the pinch gesture. Is that part of your design? Did you consider that as well? Like I want to finish my transistor with the touchscreen, not start it with it.
Please beg your pardon at the last part of your question.
Yeah. So I'm just saying, would it be part of your design? Can you integrate that, starting the gesture without touching the screen and then finishing it, terminating
just
it on
starting
the
in
touchscreen?
the air?
Yeah.
Actually, it is little different to our design goal, because our design goal is maintaining the touch gesture itself, but just to extend with natural transition in the air. So
it starts with touch.
Yeah.
Right. Okay. Let's thank